All right. One of the biggest things to note when you are trying to solve circuit problems is, well, first of all, what are you dealing with? Are you dealing with a series circuit or a parallel circuit or some combination in between, and how can you weed it down from there? Well, in this particular case, we are dealing with a purely series circuit, and we can know that there are some rules that hold true for all aspects of that series circuit. Sorry about that. The first being the fact that currents are all the same. The next thing we're looking at is the fact that the V's add, and the equivalent resistance is equal to the sum of the individual resistances. All right, and this is the way it's written on your formula sheet. So we're going to go ahead and start this particular one by looking at where do we have at least two of the three pieces of information. Well, in the case of component 3, we have both the resistance and the voltage. Using Ohm's law, we are then able to find out what is that current. And that actually helps us out a huge amount. So we look at the fact that my current is going to equal my voltage divided by my resistance. All right, pardon my very ugly R. We see that my voltage is 3 and my resistance is 5. So my I3 is equal to a voltage of 3 volts, a resistance of 15 ohms. I see a current of 0.2 amps. Because my current through resistor 3 was 0.2 amps, and this is a series circuit, and all my currents are the same, I was able to fill in the entire current column in this particular chart. Now I have 2 out of the 3 columns for 2 more pieces, so for component 1 and component 4. So for component 1, we can see the fact that my voltage is going to equal my current times my resistance. My current is that 0.2 amps we just found times our resistance of 10 ohms gives me a voltage of 10 volts. I'm going to go ahead and quick solve before I fill out the chart for 4 as well. So the voltage for 4 is equal to 5 ohms times my 2.2 amps gives me a voltage of 1 volt. So I'm able to put in my 2 volts here. I mistyped in other place, and 1 volt here. Forgot how to add suddenly, or multiply suddenly. So now I have more pieces of information. So the next thing I'm going to do is look at the fact that my voltages add. Because my voltages add, the voltage through each individual resistor is going to add up to my total voltage. I'm given the fact that my total voltage supplied to my circuit is 12. All right, so if I subtract everything else away from that 12, I'm left with what is the voltage that my second resistor is going to consume. 2 plus 1 plus 3 is 6. 12 minus 6 is 6. So we can go ahead and see that the voltage consumed by 2 is going to be 6. All right. Now we get to go back to Ohm's law, that V equals IR, to go ahead and find out what we are looking for the resistance for component 2. When we do that, we get the fact that the resistance is going to equal that V over I. So 6 volts divided by 0.2 amps gives us 30 ohms. All right, before I go ahead and wrap up, by finding the total resistance for my entire circuit. That is, if I took all the resistors and replaced it with one resistor for current to flow through, I'm going to do it twice. I'm going to do it two different ways just to show you, just to make sure that we're seeing numbers that agree, that's just a way of checking our information. We're going to use both Ohm's law and the equivalent resistance equation. If we use the equivalent resistance equation, we're adding 10 plus 30, which is 40, plus another 20 for the 15 plus 5 gives us a total of 60. All right, so that's using the equivalent resistance formula. We can also use the fact that Ohm's law does still apply, that R is still going to equal my V divided by I. My voltage being 12 divided by 0.2, again, gives me my 60. So we are good. Woohoo!